Okay, this is part 2 of that systems practice. Felt like I had to rush number 16, so I'm going to do that one again. So we need to graph these as if they're lines. Now this is a system of inequalities, kind of a review. So we've got plus 1 for our y-intercept, then 2x, so we go up 2 to the right 1, or down 2 to the left 1. Okay, then we check under the inequality. It's got a solid line, so that tells us it's a solid line. Okay, then we need to pick a test point. So a test point can be on any side. Usually I pick 0, 0. Sometimes they get a little too close, so I like to branch out. So let's pick this point 2, 0. So remember, you take that inequality and you replace the y value with the variable, replace the x value with the x variable, and then you're going to test to see if it holds true as you simplify. So 2 times 2 is 4, plus 1 is 5. Is 0 less than or equal to 5? It is if it's true where your the side where your test point is where you shade. Okay, there's our first one. Then we do it with our second one. So negative 1, slope of negative 3, so I go down 3 to the right 1, or up 3 to the left 1. Now I look at the inequality. There's no solid line, no equal to, so it's going to be a dashed or a dotted line. So the line isn't part of the solution in that. Then we pick a test point. Let's pick negative 2, 0 here. Okay, so for y, put in a 0. For x, I put in a negative 2 and minus 1. So negative 3 times negative 2 is negative 6, or positive 6. Minus 1 is positive 5. Is 0 greater than 5? No, that's false. So we don't shade that side, we shade the opposite side. And because there's more than one inequality, the answer is the double shaded region. Okay? And that's how we do a system of inequalities. Alright, now let's look at the last two. They're story problems. Let's see if we can figure these out. So it says, Jacob and Jenny each improved their yards by planting daylilies and ornamental grass. They bought their supplies from the same store. Jacob spent 16 on 4 daylilies and 1 bunch of oriental grass. Jenny spent 7 on 1 daylily and 1 bunch of ornamental grass. Find the cost of 1 daylily and the cost of 1 bunch of ornamental grass. So if you need to, think visually. So let's call these daylilies. Okay, so we had 4 of them, and then 1 bunch of ornamental grasses. Okay, so add those together, he spent $16 on it, right? Okay, Jenny spent $7 on 1 daylily and 1 ornamental grass. My daylilies suck, don't they? Okay, so in other words, 4 times D, we'll say, or X, you could call it X, plus 1 times, let's just see, B for bunch, okay, or Y, equals 16, and 1D plus 1B bunch equals 7. Well, if we think back to that task we did, I could say, well, that matches up with those two. So 7 of that $16 belongs to those two, so the rest left over, the $9, would be with those 3 daylilies. So each daylily would be $3. If each daylily is $3, then each ornamental grass would have to be 4 in order for this one to work. Okay, let's test it out using our elimination. So I've got the variables lined up here and here. These are both 1s, so I'm going to subtract. 4 minus 1 is 3. 1 minus 1 is 0. 16 minus 7 is 9. We get 3 daylilies equals $9. Divide by 3. D equals 3. Take our equation. Go 1 times 3 plus 1b equals 7. So we get 3 plus 1b equals 7. Subtract 3, and 1b equals 4. So our answer is 3, 4. Okay, so you can do it with drawing a picture, or you can do it with elimination. We could use substitution. We could have graphed them too. Okay, let's take a look at this last one. Daryl's school is selling tickets to a fall musical. On the first day of ticket sales, the school sold 1 adult ticket and 4 student tickets. So let's make adult tickets X and student Y for a total of $45. The school took in $81 on the second day by selling 1 adult ticket and 8 student tickets. Apparently, selling these fall musicals, it's not too exciting. What is the price of each of 1 adult ticket and 1 student ticket? So I guess these are actually the prices. So the first, 1 adult ticket, or X, plus 4 student tickets, or 4Y, is going to be equal to $45. The second, they made $81 by selling 1 adult ticket and 8 student tickets. Once again, you could find the difference of those because the difference is the 4 student tickets. Okay, just like we did on the activities. Okay, or with dog and cat food. Or we could use elimination, or we could use substitution. Okay, or we could graph. Let's take a look. We'll do last one. We'll do all different formats. Okay, substitution first. So I'd subtract 4y to get that x by itself. So I'd get x equals 45 minus 4y. So this x, I can then replace that x with the 45 minus 4y. Plus 8y equals 81. Now I have the y's. Subtract 45. So 81 minus 45. Borrow, that'd be 11, so 6. That would be 7, so 36. Okay. Negative 4y, positive 8y would give me a positive 4y. Divide by 4. And y would equal 9. Which tells me student tickets are $9. Then I would take one of my original equations. I could even do it in that format, because that's the same equation. And go 45 minus 4 times 9. 4 times 9 is 36. 45 minus 36 would give us $9 as well. So they cost the same amount. Okay, sometimes that happens. So where do they intersect? At 9, 9. Okay, now what if we used elimination? Well, 1x, 1x, so I'm going to subtract, because 1 minus 1 would give me 0x. Plus 4 minus 8 would be a negative 4y equals 45 minus 81 would give me a negative 36 divided by negative 4y, or just negative 4, not the y. And I would get y equals positive 9. Then I could plug it into a different equation, and I would have x plus 8 times 9 equals 81. 8 times 9 is 72. Subtract 72. Now I get x equals 9. Once again, giving me that answer. Now, what if I wanted to graph? Well, if I wanted to graph in the standard form, I would simply use a graphing calculator or Desmos and graph those. And we know the point where they would intersect would be 9, 9. Okay? However, and I think we can't use that. So draw my graph. So I would need to adjust these into slope-intercept. So I'd subtract x from both sides. So I'd get 4y equals negative x plus 45, divide by 4. So I get y equals negative 1/4 x plus 45 divided by 4. 4 goes into that 11 and 1/4. So I'd go up to about, hold on, we need a better graph for this one. Okay, so let's get our first equation. Y equals negative 1/4 x plus 11 1/4. Okay, and this is why sometimes it can be difficult to graph. That's not always the best to go if you have to change it. Okay, now x plus 8y equals 81. I would subtract by x. So 8y equals x plus 81. Divide everything by 8. I'd get y equals 1 over 8x plus 81 divided by 8 would be 10 and an eighth. Okay, so my second equation, 1/8 x plus 10 and 1/8. Okay, so these guys look kind of ugly, don't they? Okay, let's get a graph here. All right, this one will have to work. So if I go up to 10 and 1/8, okay, so 10 and 1/8 would be right about there. Now I'm going to go down 1 and to the right 8. So down 1 and to the right 8. Be right about there. Then down 1 and to the right 8 would put me out about there. Okay? Now remember, our solution is here at 9, 9. So we know it's actually going to cross at 9, 9. And this is going to be a tough one to draw. Something like that. Okay, my second one, we'd start at 11 1/4. So that'd be like up here slightly, a little higher. And we'd go down 1 to the right 4. So it'd be like right here, down 1 to the right 4. So it'd be like getting slightly closer and would end up going something like this. Okay? And it'd look like that. Now, let's use Desmos for that one as well. Okay? So we'd have our answer 9, 9 if we graphed it. Okay, now let's take a look at Desmos. So if we look at it, okay, I just wrote them in the normal way. Had I written them this slope-intercept form way, it would have been the same because of the y-intercepts. Okay, look at the y-intercepts, 11.11 1/4 and 10 and an eighth. Okay, but when they graph them, we can see that they intersect at 9, 9. So depending on whatever you called x, which we called it adult price, and y was student price, then, $9 for each one of those. And there's our answers. And there we go with part 2.